Hello and welcome to Fun Facts Online. Today, we're diving deep into this super exciting and honestly mind-bending world of quantum computing. You've probably heard about the race to build these incredibly powerful machines, but one of the biggest challenges is getting them out of the super cold, highly controlled lab environments and into our everyday world. But there's a new player in town, a concept that could change everything. Get ready to learn about qubits. For a long time, when we talked about quantum computing, we talked about qubits. Think of them as the quantum version of the bits in your regular computer, which are either a 0 or a 1. Qubits, thanks to the weirdness of quantum mechanics, can be a 0, a 1, or both at the same time, in what's called a superposition. Amazing, right? But here's the catch. Qubits are incredibly delicate. To keep their quantum states stable, they often need to be chilled to temperatures near absolute zero. That's colder than deep space. As you can imagine, this makes building and running quantum computers a massive engineering headache and super expensive. So what's the alternative? Enter the qudit. If a qubit is like a switch that can be off, on, or a bit of both, a qudit is like a dimmer switch with multiple settings. A qudit, for example, can be a 0, a 1, a 2, or a superposition of all of those. By using these higher dimensional quantum states, qudits can encode and process way more information than qubits. This is huge. It means we might need fewer quantum particles for complex calculations, which could simplify the design of quantum processors and seriously boost their computational power. And here's where it gets really exciting for practical applications. Recent breakthroughs are showing that qudits, especially in photonic systems, that's systems using light, are naturally suited for room temperature operation. No more extreme supercooling. Scientists are figuring out clever ways to create and manipulate qudits using photons, the basic particles of light. One cool method involves encoding quantum information in different properties of light, like its shape, known as its spatial mode, or its twist, called polarization. This allows them to create these multi-dimensional qudits on tiny, compact chips. This is a massive step towards quantum devices that can work without needing a cryogenics lab attached to them, dramatically cutting down hardware needs compared to old-school qubit systems. The advantages of qudits don't stop at just making smaller, warmer processors. They also offer some serious benefits for something called quantum error correction. This is absolutely critical, because quantum states are so fragile and prone to errors from environmental noise. The larger state space of qudits, basically, the more information they can hold, provides a more robust way to encode quantum information, making it less likely to get messed up. Researchers are also on the hunt for new materials and structures that can host stable qudits. Things like metal organic frameworks, or MOFs, are showing promise in keeping molecular qubits stable at room temperature, and this could be a pathway to stable molecular qudits. Another fascinating area is supramolecular chemistry, where scientists are using things like hydrogen bonds to control quantum spin interactions. This could lead to supramolecular qudits that stay coherent for longer and, you guessed it, potentially work at room temperature. So the development of practical qudits really is a paradigm shift. We're moving beyond just binary quantum information, 0 or 1, and embracing these higher dimensional states. This isn't just theoretical anymore. It's leading to new hardware and software designed specifically for this kind of mixed-dimensional quantum computing. Techniques like dynamical decoupling, which helps protect quantum states from losing their quantumness, are being adapted for qudit systems too. While the journey to large-scale quantum computers that work at normal temperatures is still ongoing, qudits are bringing that dream much closer to reality. As these innovative approaches get better and better, expect qudit-based systems to play a huge role in unlocking the incredible potential of quantum computation. We're talking about revolutions in drug discovery, materials, science, super secure communication, and even artificial intelligence. Thanks for tuning in to Fun Facts Online. We hope you're as excited about the future of qudits as we are. Until next time, stay curious.